I welcome all for this session. Today we are going to discuss a numerical solution of ordinary differential equation of first order and first degree by Runge-Kutta fourth order method. So before going to this, I recall what we studied in the previous classes. In the previous classes we are studied how to solve the ODEs by numerical method, by Taylor's method and modified Euler's method. So in the Taylor series method we have to extract the series solution, then after that particular value of x we are given and extract the particular values of y, and the same thing we are applying in the modified Euler's method also. In the modified Euler's method we have to extract a corresponding value of y for a particular point of an x. But compared to these two, so accuracy is very less. So compared to the Taylor's method, it is very good for modified Euler's method. Then compared to these two, the Runge-Kutta method gives a much more accuracy. So this is fourth order Runge-Kutta method is mostly commonly used as an and also referred as an Runge-Kutta method only. This method is more accurate compared to we are already discussed the previous two methods, Taylor's and modified Euler's method. So we are going to discuss how to see the working procedure to solve the initial value problems. Now consider the initial value problem, that is dy by dx. We treat it as a function of x comma y with initial condition y of x naught equal to y naught. Suppose we wanted to find out the next value after the y naught, which think as an y1. So that one we can write down like that, y1 equal to y naught plus k. The k can be calculated in 4 stages. So this is the formula we are used for k. The k1 is h into f of x naught comma y naught. Then k2 is an f of x naught plus h by 2 comma y naught plus k1 by 2. Then k3 is f of x naught plus h by 2 comma y naught plus k2 by 2. Then k4 equal to f of x naught plus h comma y naught plus k3. And finally we compute the k. It will take the average of this in this form 1 by 6 times of k1 plus 2 times of k2 plus k3 plus k4. So this is the procedure we adapt to solve the ordinary differential equation by Runge-Kutta fourth order method. So let us see some problems we are going to solve to understand the concept of Runge-Kutta fourth order method. So this is the first problem. So you can use the fourth order Runge-Kutta method to find the value of y of 1.1 given the initial value problem they given, dy by dx equal to x into y to the power of 1 by 3 with y of 1 equal to 1. This is the initial condition they given, and also they are giving a h. H is the step length for x values, is the point 1 they are given. So I am going to solve some problems on the board. This is the problem they are given here. So dy by dx equal to x into y to the power of 1 by 3 with an initial condition y of 1 equal to 1, and they asked to find out, and also they are giving h value 0.1. They asked to find out the value of y of 1.1. So just you write down the table, it will understand well what's the value I am going to extract here now. So this is the value of x and y. The initial value, this one we treated as an x naught 1, and the corresponding y naught, this value is also 1. So this is the first value we treated as, this one is an x naught, then the corresponding value we treated as y naught. Then they asked to find out the value of 1.1. Adding this step length, this become x1 is 1.1 and the corresponding y1 I have to put a question mark. So that we are going to find out here. We are going to find out the value of y1. We have to use the formula. Y1 is y naught plus k. Simply we can call this as an equation star. and this y1 we can also call as an y of 1.1, or simply we can call as y1. So here k can be calculated in 4 stages. The first stage k1 we have to use the formula, and also before that we have to take derivative as a function. It is an f of x comma y. It will gives like that, x into y to the power of 1 by 3. We treated this as a function. Next, then k1 have to use the formula h into f of x naught comma y naught. So this is the formula for k1, and the corresponding values we have to substitute here now. K1, h is the step length they given here in your problem. So this is your h is 0.1, and f of x naught value 1, and the corresponding value is y1. So this is f of 1 comma 1. You have to substitute in your given equation f of 1 comma 1. That simply we can write down like that, k1 equal to 0.1, then x of this one, here x is 1 and y is 1, then into 1 into 1 to the power of 1 by 3. Now after simplification of this, we have 0.1 into 1, your k1 value is 0.1. So this is the first case where I am going to find out the value of k1. Next, we are going to find out the value of k2. Again use the formula h into your x, the function will be changes like that, x naught plus h by 2, then comma, then y naught plus k1 by 2. Now use this formula. And similarly, you are going to change your function in this form, h is 0.1, and function f of your x naught value is 1 plus h value 0.1 by 2, comma, your y value, y naught value 1 plus k1 value, I have to introduce here 0.1 by 2. Now further simplification of this, f of this one is divided by this 0.1 by 2, we have 0.05, that is 1.05 comma 1.05. Now substitute this one in given function. You have to substitute here. In place of x you put it as 1.05, in place of y again you have to put it 1.05. Then after that, after simplification of this, we have 1.05 into 1.05 all to the power of 1 by 3. The simplification of this, we have 0.1067. So this will give the value of k2. Then further we are going to find out the value of k3. So use the same formula, h in place of k2, k1 you have to replace as in k2, x naught plus h by 2, comma, y naught plus k2 by 2. So that means just you have to, in place of k1 you have to replace 0.1 instead of this 0.1067. It will give k3 equal to again 0.1 f of 1 plus 0.1 by 2, comma, 1 plus 0.1067 divided by 2. Again further simplification work of this, 1.05 comma, again the 1.053, 1.0534. This is the value of k3. Then k3 I have to substitute in the given function here. What they given here? 0.1 into 1.05, 1.0534 all to the power of 1 by 3. Further simplification of this by using your calculator, we get the value of 0.1068. 1, 2, 3. Next, the last stage, we have to find out k4. k4 is again use the formula h into f of x naught plus h, comma, then y naught plus k3. Now substitute the corresponding values here. H is again 0.1, in place of this f of x naught is 1, then h is 0.1, this become 1.1, comma y naught is again 1, then k3 value 1.1063. Now I'm going to substitute this value in the given equation here. K4 equal to 0.1 into 1.1, 1.1063 all to the power of 1 by 3. The further simplification of this, we get the result in this form 0.1138. So this is the value of your K4 and this is the value of K3, K1, then K2. Now I wanted to find out the value of K. K is, I have to write down like that, 1 by 6 times of K1 plus 2 times of K2 plus K3 plus K4. Now here substitute all the values of here K1, K2, K3 and K4 here. Then simplification of that, we get the value of K in this form 1.1068. Sorry. So that is 0.1068. Then after that, this K value you have to substitute in equation star, so that will give the required value of y1. So then substitute the value of K in the equation star, it will gives like that. Then y of 1.1 is y naught value 1 plus your K value is 0.1068. So totally we have 1.1, the value is 1.1068. So this is the required solution of the ODE by using Runge-Kutta fourth order method. Now I am going to solve some more problems. Next problem, take on the next problem. Again use fourth order Runge-Kutta method, find the value of y of 0.2 they given, and also derivative also given. There is initial value problem, dy by dx equal to 3x plus y, that is y of 0 equal to 1. So again by data, these are the things I have to write down here. Derivative we think as a function f of x comma y equal to 3x plus y, and also I write down the initial condition, your x naught value here 0 and the corresponding y naught value write it as 1, and they asked to find out the value of y at the point 0.2, that one we treated as x1, and the corresponding y1 they asked question mark, that we are going to find out. Here h is not given, we should have to find out the value h by take the common difference of the first term of x to next term, that is 0.2 minus 0 will give you a h, that is the step length 0.2. Now we are going to find out the y of 0.2, we simply called as an y1, that is the next value of your x, and we use the formula like that y naught plus k. Now call this as equation star. Now again k can be calculated as follows. Here k1 is h into f of x naught comma y naught, already I read in the previous problem. So h is 0.2, that will be given, f of x naught value 0 and the corresponding value of y naught is 1. Now substitute in your function k1 0.2, 3 into 0, that is x naught value plus 1. After simplification of this will give the value of k1, that is 0.2. Then again k2, this is the formula we are used, h into f of x naught plus h by 2 comma y naught plus k1 by 2. Then h value are substitute as a 0.2 and your x naught value 0, h value here 0.1 by 2, this is the formula. Then corresponding y naught 1 plus 0.1 by 2. Again k2 is 0.2, then f of 0.1 comma 1.1. Now these value substitute in the given function, that is a derivative, we get like that. After simplification of this we get 0.2 0.28. Then the same thing for K3, h of x naught plus h by 2 comma y naught plus K2 by 2. Here x naught as usual 0 and the corresponding h is 0.2. Now substitute here. Simplification of this, we get K3 is 0.2 into f of 0.1 comma 1.14. Now these value you have to substitute in the given function. We get like that 3 into 0.1 plus 1.14. The simplification of this will give K3 value, that is 0.288. Then K4. This is the formula, h of f of x naught plus h comma y naught plus K3. Here K4 is 0.2. Then again x naught value 0, h is 0.2. Now substitute here the corresponding values of y naught and K3. After simplification of this, we get K4 value 0.3776. Then you take all the values of K1, K2, K3 and K4, substitute in K, the formula. This is the formula we are used here, K 1 by 6 times of K1 plus 2 times of K2 plus K3 plus K4 with y naught. This is the formula we are used to find out the value of y1, y naught plus K. Now simplification, substitution of all these values in this equation, finally we get the value of y of 0.2 is 1.2856. And also remember one thing, in your syllabus they mention only for find out the solution for only first stage, not for asking for second and third stage. That's why we are solving problems only for first stages. How to find out the, after find outing the value of y naught, they asked to find out only y1. So next problem we are taking now. Again use the Ringe-Kutta method of fourth order, solve this equation. I am going to solve this one here. So here solve y square plus x square into dy is equal to y square minus x square into dx with an initial condition they given here, y of 0 equal to 1, and they asked to find out y at the point x equal to, find y at x equal to 0.2 with also given h value is 0.2. So first you have to find out the derivative of this function, that is dy by dx. I have to send it here now. So and send it this one here, y square minus x square divided by y square plus x square. So this is the function we treated as, and the corresponding initial value y of 0 equal to 1. This one we treated as a function, that is an f of x comma y is y square minus x square divided by y square plus x square. And also have to implement the table. So that will give how, which value I am going to find out the corresponding values of y. So here x value, here x naught is 0 and the corresponding y naught value is 1. They asked to find out 0.2. Here x1 is 0.2 and the corresponding y1 is question mark. Again you take the h value is 0.2. Then we are going to find out the y1 is simply y naught plus k. Now call this as equation star, and also k can be calculated in 4 stages. Here k1, again use the formula h into f of x naught comma y naught, and here k1, h is the given value 0.2, then f of x naught 0 comma 1. Now substitute this in the given function here. It will give the k1 value 0.2 into 1 square minus 0 square, 1 square plus 0 square. Here x value 0 and the corresponding y value 1. After simplification of this we get 0.2. That is k1 value. Your k1 value is 0.2. Then again k2. Use this formula h into f of x naught plus h by 2 comma y naught plus k1 by 2. Use this formula. So again h value is 0.2 and the corresponding value of x naught is 0 and h by 2. F of 0 plus h by 2, here h is 0.2 by 2, this one is 0 plus 0.2 by 2 comma y naught value 1 plus k1 value 0.2 by 2. After simplification of this, it is an f of 0.1 comma 1.1. Now substitute in this equation, we get the value of k2. k2 is equal to 0.2 into 1.1 whole square minus 0.1 whole square, then whole divided by 1.1 whole square plus 0.1 whole square. After simplification of this, we get the value of 0.67. This will give the k2 value. And similarly, corresponding k3 value we also find out here now. k3, in place of k1 you put it k2, that is h into f of x naught plus h by 2 comma then again y naught plus k2 by 2. k3 is equal to 0.2, then f of 0 plus 0.2 by 2 comma 1 plus 0.1967 by 2. We get k3 equal to 0.2 into f of 0.1 comma the simplification of these values will give 1.0984. Now these values of x and y substitute in the given equation, we get the value of k3 0.2 1.0984 whole square minus 0.1 whole square divided by 1.0984 whole square plus 0.1 whole square. Now simplification of this by using your calculator, we get the same value 0.1967 accuracy. Then you have to find out the value of k4. k4 is h into f of x naught plus h comma y naught plus k3. Again, as usual, I have to substitute all these corresponding values. We get here now 0.2, then f of 0 plus h is 0.2 comma y naught is 1 plus, that is 1.1967. Now substitute in the given function here. I'm going to substitute these values here now. Again 1.1967 whole square minus 0.2 whole square divided by 1.1967 whole square plus 0.2 whole square. Now simplification of this, we get the value of k4. k4 is 0.1891. Now again, take down all the values of k1, then k2, k3, k4, substitute in the k. So your k comes like that. Now substitute the values of k. Now k is again 1 by 6 times of k1 plus 2 times of k2 plus k3, then k4. Now substitute corresponding values of k1, k2, k3. Your k1 is 0.2 plus 2 times of k2 plus k3, 0.1967 plus 0.1967 plus k4, 0.1891. After simplification of all these values, we get the k value in this form 0.196. Then substitute this k in equation star. Your equation star becomes like that. Your equation star becomes, that is y of 0.2. Simply y1 is y0 plus k. y0 is 1 plus 0.196, that is 1.196. So this is the values of y1. So to substitute in this table, so that will give the corresponding values of y1, that is 1.196. Similarly, I am going to some more problems on my slides. So just next problem. Again, employ the fourth order Runge-Kutta method to solve the equation. This is the next problem, that is dy by dx equal to 3x plus y by 2 with initial condition y of 0 equal to 1. At x equal to 0.1, again they ask you take the value h as a 0.1. So as usual, by data you can write down all the things. Dy by dx equal to f of x comma y. So that function we treated as 3x plus y by 2. And also have to prepare the table. What we are going to find out the values. x0, this is your x0 is 0, and the corresponding value of this one we called as an y0 1. And they asked to find out the value of y at the point x1. We treated as x1 is 0.1, and the corresponding value of x1 y1 is a question mark. So that's we are going to find out. Again, y1 we treated as y0 plus k. Call this as equation star. So here also the k can be calculated as follows. Here k1, so it is an h into f of x0 comma y0. So k1, so in place of h you put it as 0.1, then f of x0 value is 0 and the corresponding y0 value is 1. Now substitute in the given equation, that is function, your k1 will give 0.1 into 3 into x0 value 0 and the y0 is 1 by 2. After simplification of this term becomes 0, 1 by 2 is 0.5, 0.1 into 0.5, it will give k1 value as a 0.05. Then k2, h into f of x0 plus h by 2, then again y0 plus k1 by 2. Now take down all the datas what they given, you have to substitute here. H is 0.1, f of x0 is as usual 0, 0.1 by 2, 1 plus 0.05 by 2, this is the k1 value. Now of simplification of these things using your calculator, we get f of 0.05, that is x value, and the corresponding y value 1.025. So take these x and y values, substitute in the given function, that is f of x comma y. So that is 3 times of x, that is 0.05, plus y is 1.025 divided by 2. Again simplification of these terms, we get k2 value as a 0.0663. Next k3. Now substitution for the k3 values, again use the formula h into f of x0 plus h by 2 comma y0 plus k2 by 2. Then again h is 0.1, then f of x0 value 0, and again h value is 0.1 by 2 comma y0 is 1 plus k2 value what we obtained in the previous is 0.0663 by 2. Now simplification of all these things, we get the equation in this form. Now take this x and y value, substitute in the given equation. K3 is 0.1, 3 times of 0.05 plus 1.0332 by 2. Now simplification of this by using your calculator, we get the value of K3 is 0.0667. Now find out the value of K4. K4 is h times of f of x0 plus h comma y0 plus K3. Then K4 is, it's a 0.1 to f of 0 plus 0.1 comma 1 plus 0.0667. Now simplification of these things, we get like that. 0.1 is the h value keeping as it is. The x0 plus h value become 0.1 comma 1.0667. In K4 is 0.1 into 3 into, this is the given function. A substitute here, the x0 is 3 into 0.1 plus 1.0667 by 2. Now simplification of all these things, we get the K4 value as in 0.0833. Now take on all the values of K1, K2, K3 and K4, substitute in the given equation as in y1 equal to y of 0.1. So this is the formula, this is y0 plus 1 by 6 times of K1 plus 2 times of K2 plus K3 plus K4. Now substitute all these terms what they have obtained in the previous case, K1, K2, K3. We get the value of y of 0.1, that is 1.0666. So this is the corresponding values of y at the point x equal to 0.1. So one more problem. That is the, again they ask the same method, doing a Kutta method to solve the equation that here 10 will be appear here, 10 into dy by dx plus x square plus y square with y of 0 equal to 1 at the point x equal to, again they asked for 0.1. You have to remember one thing, the derivative coefficient should be always 1. Here the 10 will be given, that should have to send to right hand side. You have to make the equation in this form. So there is a derivative, coefficient should be always 1. So that's why you send 10 to here, its function will become x square plus y square all divided by 10. In a similar way, the corresponding data I have to write down. X0, this is the x0 value, that is 0, and the corresponding values of y0 I have to write down as in 1. And x1, they asked to find out this value 0.1. So this is the value called as 0.1. Again y1 is the question mark we are going to find out. The difference of these two, x0 and x1, that is the step length, we taken as in h, that is 0.1. Sometimes they mention in the problem, sometimes they doesn't mention in the problem. If it not mentioned in the problem, you have to take the difference of these two, x0 and x1, it will give the values of h. So here as usual, they asked to find out y of 0.1, that is simply y1. So again use the same formula y0 plus k. So k can be calculated as follows. So this is your k1 formula, h times of f of x0 comma y0. Then k1, I have to substitute here, h value is 0.1, your x0 is 0 and the corresponding y0 is 1. So again k1 value is 0.1 into, so this is the given problem, it is x square plus y square by 10. You have to use here now this is 0 square plus 1 square by 10. Simplification of this will get 0.1. Multiplication of these two will get k1 value as in 0.01. Then again k2, h times of f of x0 plus h by 2 comma y0 plus k1 by 2. The same formula, no changes, just only the data I have to substitute here now. H is 0.1, f of 0 plus 0.1 by 2 comma 1 plus 0.01 by 2. This is again k2. A simplification of all these things, we get the equation in this form, f of 0.05 comma 1.005. Now these data of x and y you have to substitute in the given equation, that is an x square plus y square by 10. You have to substitute in place of x as 0.05 and in place of y 1.005. Simplification of these things will get the value of k2, that is 0.0101. So this is the value of k2. Then again k3 I have to find out, h into f of x0 plus h by 2 comma y0 plus k2 by 2. Then h is as usual 0.1, then x0 is 0, h is 0.1 by 2 comma 1 plus 0.0101 by 2. Now simplification of these two will gives f of 0.05 comma 1.0051. Substitute these x and y values in the given equation, we get the value of k3 in this form, again 0.0101. Then k4, h into f of x naught plus h comma y naught plus k3, then again k4 value is 0.1. Now substitution of these things, we get the value of 0.1 comma 1.0101. Now substitute these values in your k4, we'll get the, after simplification, we'll get the k4 value is 0.0103. Now substitution of all this k1, k2, k3 in this formula, we get the required value of y of 0.1, that is 1.0101. Then after that, I will give you some exercise to you. So use these exercise problems and you get the solution by Runge-Kutta fourth order method. So, thank you. Close.